Hi friends, today we are going to discuss the chapter liquid state. In that we are going to discuss the property of liquid, that is viscosity, for FYBSC Chemistry student. The content of the topic are concept of viscosity, viscous versus mobile liquid, definition of viscosity, what are the units of viscosity, Poiseuille's equation, factor affecting viscosity, Ostwald viscometer, problems related with this topic, and the summary of the content. So, viscosity. Liquid flow when a shearing force is applied. Layers of liquid slide over each other with different velocities. A layer in contact with a stationary surface has zero velocity and the upper layers move faster. The internal friction between the layers resists this flow. This resistance is called viscosity. So friends, see here in this figure, this is the stationary plane and the liquid consists of different molecular layers. So these are the different molecular layers, and this is stationary phase and the upper one is mobile phase. So the molecular layer of the liquid which is in contact with the stationary plane is having less velocity, that is v is equals to 0, and the molecular layer which is away from this stationary plane, that is in contact with moving plane, or we may say it is a moving plane, so it has maximum velocity, that is Vmax. So due to difference in velocity between the different molecular layers, there is a resistance is created. So this resistance, whatever the resistance generated, that is called viscosity. That is the frictional force of resistance is called as viscosity. Then we will see the viscous versus mobile liquids. So some liquids are highly viscous while some liquids are highly mobile, means they are less viscous. So highly viscous liquid means they move very slowly, their flow is very slowly. For example, we have observed in daily life in our house, that is edible oil, castor oil or glycerin. They have highest viscosity, means they move very slowly. And the low viscous liquid, that is water, benzene, they have less viscousness, therefore their mobility is faster, so they move fastly. That's why they are called as mobile liquid. So viscosity measures the frictional resistance between the moving liquid layers. So these are the figures with increasing viscousness. So water is less viscous, therefore it is more mobile. Olive oil, it is medium viscous, and the honey, it is highly viscous liquid. So we have observed these examples in our daily life, that honey is highly viscous liquid which moves very slowly. Then what is the definition of coefficient of viscosity? So consider two parallel layers separated by distance dx. So dx is the distance between two parallel layers which are moving with a velocity difference of dv, and area is a. So frictional force is directly proportional to area. It is directly proportional to the velocity. More the velocity difference between two molecular layers, more will be the frictional resistance. More the area of the liquid, more is the frictional force. And it is inversely proportional to the distance. Means if the two molecular layers are far away from one another, then the frictional resistance produces less. So it is inversely proportional to the distance between the molecular layer. So if we combine all these three parameters, area, velocity and distance between molecular layer, the equation becomes capital F is equals to eta into capital A into dV upon dx, where eta is called as coefficient of viscosity. So definition of viscosity is, eta is the tangential force per unit area required to maintain a unit velocity gradient between two molecular layers 1 centimeter apart. So definition of viscosity is very simple, that is the frictional force per unit area required to maintain a unit velocity gradient between two parallel layers which are 1 centimeter apart. So two molecular layers to maintain the velocity of 1 centimeter per second, the whatever the force is required, that force per unit area is called as viscosity of that particular liquid. Then what are the units of viscosity? So if we see from this equation, the dimensions of viscosity, that is eta, are mass into length inverse into time inverse. Generally mass is expressed in gram in CGS unit, length is expressed in centimeter, therefore centimeter inverse, and time is expressed in second, therefore it is second inverse. So CGS unit is gram per centimeter per second, or it is equivalent to poise. So poise, it is the unit of this viscosity is name is given poise from the scientist Poiseuille's, because he has given the equation to determine absolute viscosity of any liquid. From the name of the scientist, the unit of viscosity is given the poise name. So these are the conversion. 1 centi poise is equals to 10 raised to minus 2 poise, or 1 milli poise is equals to 10 raised to minus 3 poise. Then some viscosity values are given at 20 degrees centigrade in that are expressed in poise. So for benzene it is 0.00652 poise. For carbon tetrachloride CCl4, the value is 0.00969. For ethanol it is 0.012. For ether it is 0.0023, and for glycerin it is 14.9, and water it is 0.0101. So from these values we have observed that as the solvent is different, so viscosity is different. So it depends on the viscosity, depends on nature of liquid. As the nature of the liquid changes from liquid to liquid, therefore these values are changes. So glycerin is highly viscous liquid among all these. Then what is Poiseuille's equation? So Poiseuille is a scientist, and he has given an equation to determine the absolute value of viscosity of the liquid. So eta is equals to pi pt r raised to 4 upon 8 phi. So in this equation, P is the pressure difference between 2 points or two bulb of a viscometer. R is the radius of the capillary expressed in centimeter. L is the length of the capillary expressed in centimeter, and V is the volume in time t. So V is the volume of the liquid which passes from through the capillary, and the t is the time required for to pass the liquid from point from upper layer to lower layer for fixed volume of liquid. So by using this equation we can determine absolute value of viscosity of any liquid. But there are some technical difficulties to find the accurate values of pressure difference, radius of capillary, and the length of the capillary. So the correct or accurate value of viscosity cannot be measured by using this equation. So we use another equation, that is we use relative viscosity. So we use to determine the relative viscosity of the liquid. So what are the factors affecting viscosity? So temperature, then structure, shape of the liquid, as well as pressure. These three factors affect the viscosity of the liquid. So as the temperature increases, viscosity will be decrease, because as temperature increases, internal energy of the molecules increases, and therefore the viscousness decreases. Molecular structure, it also affects the viscosity. How? That is, larger molecules are more viscous than the smaller molecule. So larger molecule have more viscosity than the smaller molecule, as well as it depends on the shape of the molecule. That is, rod shaped molecule are more viscous than the spherical molecule. So in this way, shape and size of the molecules, molecular layer of the liquid also affect the viscosity of the liquid. Another parameter is pressure. So increasing the pressure increases the viscosity. As the liquid comes closer and closer, attractive forces between molecule get increases, and therefore the viscosity of the liquid also increases. So it is directly proportional. This factor is directly proportional. Then absolute value versus relative viscosity. So to determine the absolute value of viscosity, we need to use Poisson's equation, that is pi pt r raised to 4 upon 8vl. But um, exact value of the viscosity cannot be determined by using this Poisson's equation, because the exact value of pressure difference between the two bulb of the viscometer cannot be determined exactly, and therefore we have to determine the relative viscosity of the two liquids. So generally for this liquid, consider two liquids A and B flowing through the same capillary with same volume. So eta A upon eta B is equals to Ta dA upon Tb dB. So Ta is the time of flow of A liquid, dA is the density of A liquid, Tb is the time of flow of B liquid, that is reference liquid, and dB is the density of reference liquid. Generally reference liquid is used that is water, having known viscosity, and its only density and time of flow are to be determined by using viscometer. So how this viscosity is measured? So viscosity of any liquid can be measured by using an instrument, that is a glass pipette, that is called as Ostwald viscometer. So it is the name of scientist, that is Ostwald, and he discovered this instrument to determine the viscosity of any liquid. So it is a glass pipette. It is made of glass and it has two bulbs. It is a U-shaped tube having two bulbs, that is bulb B and bulb A, and this it has two arms. One arm is called as capillary arm because here capillary is there, and another arm is called as clamping arm. So it is this instrument is clamped to the stand. Therefore, it is this arm is called as clamping arm, and this arm is called as capillary arm because this arm has capillary, and it has two layers, upper marking and lower marking. So we have to determine the time of flow of any liquid, how it takes the time to pass from this upper marking to this lower marking, and the time of flow of known liquid as well as unknown liquid can be determined. So we have to put the liquid in the bulb A. It is to fill 2/3 of bulb A, and then the liquid is sucked from this capillary arm by means of mouth. So this liquid is sucked upward up to point B, up to this upper mark, and then allowed to pass through this capillary, and time of flow of this liquid is determined or observed in second. So time of flow of liquid A, that is unknown liquid, is measured, and similarly for known liquid, that is reference liquid, that is water, the time of flow, that is Tb, is measured for same volume of liquid. So in this way, depends on the time of flow and the density of liquid, we can determine the relative viscosity of the unknown liquid. So using this relative viscosity equation, eta A upon eta W is equals to Ta into dA upon Tw into dW. So we have to determine the viscosity of unknown liquid, that is liquid A. Therefore eta A is equals to eta W into Ta dA upon Tw dW. So in this way, Ta is the time of flow of unknown liquid, and dA is the density of unknown liquid. Tw is the time of flow of water, that is reference liquid, known liquid, and dW is the density of reference liquid, water, that is known liquid. So and eta W is the viscosity of water, that is reference liquid. In this way, we can determine the relative viscosity of the any unknown liquid. Then in our exam ask some problems related with this viscometer, Ostwald viscometer. In this case, we have given time of flow, time of unknown liquid as well as known liquid, density of both liquid is given, and the viscosity of water, that is reference liquid, is given. We have to determine the viscosity of unknown liquid, any organic liquid. other than the water. So let us see the problem. In an experiment with Ostwald viscometer, the time of flow of water and ethanol are 79 seconds and 170 seconds at 20 degrees centigrade. The density of water is 0.998 gram per centimeter cube. Calculate the viscosity of ethanol if the viscosity of water at 20 degrees centigrade is 0.01008 poise. So we have given time of flow of ethanol, that is TA. We have given time of flow of water, that is TW. Also we have given the density of water 0.998 gram per centimeter cube. Also we have given density of unknown liquid dA, that is 0.791 gram per centimeter cube. And in this way viscosity of water reference liquid is given 0.01008 poise, and we have to determine the viscosity of unknown liquid, that is liquid A, ethanol, that we have to determine. So by our equation is of relative viscosity is eta A upon eta W is equals to TA dA upon TW dW. So by putting these values of time of flow of ethanol, density of ethanol, time of flow of water, density of water, and this is the viscosity of water, which is multiplied with these values. So in this way we can determine the viscosity of unknown liquid, that is ethanol, that is come out to be 0.01719 poise. So in this way we can solve the problem related with this topic. So we can summarize this topic here. We have seen that viscosity is nothing but the internal friction between the liquid layers, which depends on the temperature, molecular structure of the liquid, as well as pressure of the liquid. And this viscosity can be measured by means of Ostwald viscometer, that is a glass pipette which is used to determine the time of flow. So we can determine relative viscosity of any liquid. So in this way we have completed this topic, that is viscosity of liquid, and you must understand this topic. So thank you friends.